finding the surface area of a pyramid. In the past, we've looked at the surface area of prisms. Surface area of pyramids are a little different. The big difference in the surface area of pyramid is this piece right here. It's going to grab, which it isn't okay. But this one right here. When we're finding the surface area of the pyramid, we have to be concerned with something called the slant height of the pyramid that is on the face of the pyramid, because unlike with prisms where we have rectangular sides, here when we look at our unfolded pyramid, we can see that our sides are really triangles and not rectangles. And of course, the way we find the area of a triangle, if we were to do that, is we take the base times the height and divide by 2. Now, we're only going to be working with pyramids with regular bases, so we don't have to worry about anything special here, and these are always going to be isosceles triangles, which kind of makes things a little bit easier. But this height is what we're going to refer to as our slant height. Of the pyramid. The height of that triangle is the slant height of the pyramid. And on the face of the pyramid, it looks like you see on this red line right over here. So the slant height is used to help find the surface area of the pyramid. Now, once we get that, it's pretty easy to find it. Our formulas are going to be a little bit different. The trick is going to be finding that slant height. Now, oftentimes when we're looking for the slant height, we're going to have to solve the triangle that's in the green, red, and kind of purple side here, where we've got the height of the pyramid here indicated in green. That's the actual height from the vertex down to the center of the base. We've got the slant height of the pyramid indicated here in red, and the apothem of the base, because the base is a regular polygon, it has an apothem. In this case, it's a square base. That apothem is just half the side of the square, so it's really simple. We have the apothem, and those three together form a right triangle, where the slant height is the hypotenuse of the triangle. So oftentimes we find ourselves having to solve that right triangle in order to find the slant height. Sometimes we're given the slant height. That's really easy. But a lot of times we aren't, and we have to figure that out. The other triangle that we might have to solve in order to do this uses what's called a lateral edge of the triangle. And this is a little more unusual, but it can happen where we have half a side down in the bottom here. This is half the side. We have a lateral edge and the slant height. This is all in the face of the pyramid. So nothing's internal this time. Everything's on the face of the pyramid. In this case, the slant height is one of the legs of the triangle. But again, this is a little bit more unusual. And again, we solve that using Pythagorean theorem in most cases. Let's take a look at a couple actual examples. Here I have a square-based pyramid. Now, you'll notice that things are not that different from when we were dealing with prisms. And now we still find the perimeter of the base area, the lateral area, and the total area. A couple things are going to be different, though, and that's indicated in our formulas down here. First off, the lateral area, which before for prisms was perimeter of the base times the height, that's not going to work anymore because we don't have rectangles, we have triangles. So it's perimeter of the base times slant height now divided by 2, and the divided by 2 is because they're triangles. The total surface area is also a different formula for pyramids because unlike with prisms where there are 2 bases, pyramids only have 1 base. So it's a lateral area plus just 1 base. So actually it's a little bit easier. I don't have to remember to multiply the bases by 2. Let's take a look at that in action. So first off, we can find some things. Perimeter of the base. The base in this case is a square. So finding the perimeter, pretty simple. 12 times 4 is 48 centimeters. And based on that also, I can also very quickly find my base area. Because it's a square, 12 times 12 is 144 centimeters squared. So we've already got that figured out very quickly. Slant height is where it gets a little bit tricky. So let's work on it. I have 8 centimeters here, but that's the actual height of the triangle. That goes from the vertex up on top down to the center of the base. Now, because the square base is pretty simple, this length right here, we know it's going to have to be half of the side, so 6 centimeters. That doesn't hold true on other shaped bases, but square bases, it's always half the side there. So that's really nice. And now we have our right triangle that needs to be solved. 6 squared plus 8 squared equals my third slant height here, slant height squared. So 36 plus 64 is 100 equals slant height squared, so slant height is 10. So basic Pythagorean theorem, basic right triangle solving, just like we've been doing for a while. Just like with pyramids, with prisms, once I found these three things, finding the last two are pretty simple. The lateral area is the perimeter of the base times the slant height divided by 2. So that's 48 times 10 divided by 2, which is 240 centimeters squared. The total area is the lateral area plus 1 base. So that'd be 240 plus 144, which is 384 centimeters squared. And again, today we were only worried about the surface area. We'll worry about volume tomorrow. So this is just how to find the surface area of a pyramid. Cones work essentially the same as pyramids, although cones are technically not pyramids because they have a circular base instead of a polygon base. The formulas really don't change. We do have to remember our formulas for circles, though, and there's a quick reminder of that. Nice thing about cones is that the radius is one side of my triangle to find my slant height, and the slant height is a constant all the way around the cone, so it's really a little bit simpler triangle situation. So let's go ahead and rip this one pretty quickly. The perimeter of the base has to be the circumference. It's pi times diameter. The radius is 5. Okay, my radius is 5, so my diameter would have to be 10. So my perimeter would be 10 pi, and again, remember your units, meters. My base area, we can also get that very quickly. Pi r squared, the radius is 5, so that's 25 pi meters squared. Slant height is always the interesting one to find, but we're given the actual height is 12. So 12 squared, we're given the radius is 5. And again, remembering that 169 is the slant height squared, I want to get L, not L squared, so I take the square root of 169, which is 13 meters. Once I found that slant height, again, we use our formula. Lateral area is perimeter of the base times slant height divided by 2. So 10 pi times 13 divided by 2 will be 65 pi square meters. 130 pi divided by 2, 65 pi. The total area is going to be the lateral area plus the base area, so we simply add these two. 25 and 65 pi gives me 90 pi meters squared for my total surface area. So again, not a whole lot of new formulas, a couple of them, but the big thing is we do have to solve for that slant height. Let's do one more example, the tetrahedron. This time you're actually given the slant height, which is going to make life a whole lot easier. At the same time, my base is an equilateral triangle. That's a tetrahedron. All sides are equilateral triangles, actually. So we can go ahead and just follow our protocol and do this. So my perimeter of my base is 18 centimeters. 6 plus 6 plus 6 is 18. My slant height is given at 3 root 3 centimeters. My base area, now we got a little work to do. We have to remember our formula for an equilateral triangle. It's side squared root 3 over 4. So that's 6 squared root 3 over 4 is 36 root 3 over 4, which is 9 root 3. So my lateral area is going to be the perimeter of the base times my slant height divided by 2. 18 times 3 is 54, divided by 2 is 27. Squared for my areas. And finally, 9 root 3 and 27 root 3 gives me 36 root 3 centimeters squared. We have our total surface area. Can anyone think of an easier method for this? Well, since you're really not here to answer the question, tetrahedron, every side is a congruent equilateral triangle. So if I want the surface area, really I just need to find the area of one side, which would be the base, and multiply that by 4, because all the sides are exactly the same. It's a tetrahedron. Kind of like a cube, where every side is the same square. If I find the area of one side, I can just multiply by 6 to find the surface area. This is the triangle equivalent to that. And 9 times 4 is 36. 3 centimeters squared. So it's an alternate way of doing a tetrahedron. It only works with a tetrahedron, but it's kind of nice. Really, what it comes down to, if you want a formula for the surface area of a tetrahedron, it's just side squared root 3. Because divided by 4 and times 4 cancels out. That's our formula for the surface area of a tetrahedron. You do not have to memorize that. That will not be on the test. But for some people who like formulas, that might be useful. So that's our podcast for today. Finding the surface area. To summarize just our formulas one more time. Okay, the lateral area for a pyramid is perimeter times slant height divided by 2. The total area for a pyramid is the lateral area plus only one base. That's our podcast. Please write down at least one question that you have based on this podcast. Bring that in as evidence of you watching that podcast. One question that you did not have answered as part of this podcast, or one question you have after watching it. And that's how I'll evaluate it. All right.